Okay, so in this video, I'm going to show you how to solve for the distance that the tree is, or whatever object you have is away, and how tall it is. Okay, and then as well as some any sort of like quirks that can happen along the way. So first off, let's just go ahead and solve this. There's no right angle, so I need to do the law of sines. And the law of sines says I take this unknown here, d, and I divide it by the sine of the angle across from it. That's 87 degrees. And that equals, so d over 8 sine of 87 equals, and then I pick the side I do know, in this case 142 inches, and I divide it by the sine of the angle across from it, so the sine of 3 degrees. Okay. And then on my calculator, because this is just the distance divided by, in order to solve where the unknown is being divided, I just need to multiply. I just need to times sine 87 times that thing. Well, the process to do that is a little bit slow, but not too bad. So I'm going to type in 142 divided by the sine of 3. Make sure my mode's in degrees. Sure is. Hit enter. And so there we go. There's what this side, that's what the number is here. I wanted to figure out what that is first. So once I know that number, all I have to do is multiply by sine of 87 because it's being divided over there. So to get rid of it, I multiply. So times the sine of 87. And I have an answer here, 2,709.5 inches roughly. Okay, so it's approximately. And we'll eventually convert this into feet because it oftentimes makes a lot more sense to do so. Okay. And what I'm going to do is I'm going to go ahead and leave that on my calculator. If I want to be super accurate, I'm just going to leave it right here. I've written it rounded, but I can also just leave it in my calculator because I'm going to need it. So now I know what this is. This is approximately 2,709.5 inches. So now once I know that, it's the same problem that I had before, where if I identify this angle right here at the ground, if I identify the sides, that means that this is the hypotenuse, and this is the opposite, and this is the adjacent. And I want to know the height, which is the opposite, and I know the adjacent, which is the distance, so that's going to be tangent. So I set up my tangent equation, which would be the tangent. Oh, this pen's never been used before. The tangent of 12 degrees of this angle here is the opposite, which is h, divided by the adjacent, which is 2,709.5. Okay. And then to solve this, it's h divided by, so I just need to do this number times the tangent of 12. Okay, so I'm going to do that, and then I'm just going to type times, because I just want to take that number, which I already have in my calculator, times the tangent of 12, and there we go. Okay. Now, because it doesn't really make a ton of sense to talk about our height of a tree in just inches, I'm going to divide by 12, so I have it in feet to convert back to feet. So here I have something, oh, that's pretty close to just 48 feet if I round it there to the nearest decimal place. Okay, so my height is about 48 feet. Okay, and I'm going to go back and let's go ahead for good measure and divide this distance number. I'm going to write the whole thing here and divide it by 12. And I get about 225.8 feet. Okay, if I want to have them both in the same unit, 8 feet there. Okay, so now what I know is that my tree from my spot was about 225.8 feet away from that spot that I was measuring, and that the height of the tree is about 48 feet tall. Now I said that there are some quirks here in this process, and I do want to outline them. If you want to be extremely precise, there can be some problems. Number one, over here when we were doing the tape measure thing, you needed to make sure that this tape measure, the corner of that tape measure was actually the spot you were measuring distance from. And if it wasn't, like in my video, I was about, a few inches away, I would need to mark that mark and figure out how many inches it was, and then add it to my measurement. So if it was like 4 inches away, I would need to add 4 inches to my distance before I go do this height thing. So you need to make sure that this number is finalized, and any sort of quirks that might be in your process, in your measurement, are updated before you use it here. Likewise, in this, when I figure out that this is 48 feet, what I'm actually figuring out is how far above where I'm at right here is the tree, how far vertically. But if that tree is beneath me, it starts beneath me, then the tree's actually taller, and I'm going to need to figure out, if I want to figure out how tall the tree is, I'm going to need to figure out how much further below it is. Or if it's up on a hill, well, then I'm just figuring out how far it is, including the hill that it's on. So my example, the tree was up on a hill. So I'm figuring out how far it is above me from my point. And so if I wanted to figure out, well, how far, if it's on a hill, I would need to do this process and go out and measure the angle to the hill so that I would know how big the hill was, and then I could take the hill's measurement and subtract it from there. So say the hill was 5 feet tall, I would take 48 feet and I would subtract the hill out of it. So if you want to be extremely precise, those are processes that you can do. And by the way, if you're going for the exceeding level, I'm asking you to do this process twice. So it is possible, say it was a tree on a hill, to choose the tree as your one thing, to find its distance to the tree and then calculate whatever, and then have the hill it's on be the other thing so that you can figure out exactly what the tree is. That's totally possible to actually include it all into one, and have that be your two examples of combo. So just a thought there. But there you go. The crazy thing about this is that we used a tape measure, protractors, and just two things to make sure we're pointing in the right direction. And as long as we have the tools to do it accurately and we can measure it accurately, we can figure out how far something is and how big it is without ever needing to directly measure it.